Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this session, we'll be illustrating the use of HSR and HSM on the mold as shown on the screen. We'll be doing this on a 3-axis machine. The operations that we'll be using in HSR and HSM will include roughing cuts, SemiFinish, and finish cuts as well. Now, our first operation will be our roughing cut using HSR, and if we open up the operation, you can see we'll be using HM roughing. The tool that we'll be using will be a 16 millimeter end mill, and if we go down to our passes, you'll note that we're leaving a 0.5 millimeter of offset on the wall as well as on the floor, plus we'll be stepping down every 1.5 millimeters. Also note that we'll be using the option in our step over type of HM spiral, allowing it to work well on a part such as this, coming in from the outside as well as working well on inside pocket areas. And we'll also have it set up at constant and flats. If I were to run the simulation, you'll note that the part is being machined from the outside, working its way in, doing the complete rough cut. Getting rid of the tool path, you can actually see the actual cut that's actually being done on the part itself. Now, the next HSR operation that we'll be using will be for rest roughing. For rest roughing, we'll be using a bullnose tool of 8 millimeters with a 2 millimeter radius. And if we go into our passes, you'll see that this time we'll be stepping down every millimeter, breaking down the large steps that were left over in the previous operation, but still maintaining the same wall offset and floor offset for our semi-finish and finish cuts. Again, taking a look at the simulation, you'll see that the rest rough only works in the areas where the previous tool was not able to work, and also machining smaller steps and working only on the areas where there is material to be taken off. In our next operation, we'll start with our HSM operations of semi-finish using constant Z, working only on the steep areas of the part. If I were to open up the operation itself, you can see that we're working in constant Z machining. I've also used applied fillets so that when the tool gets to corners, it won't make any sharp turns. The tool itself will be a 10 millimeter ball end mill. And if we go into our passes, you can see that we'll be leaving now 0.25 millimeters on the wall and the floor to be left over for the finished operation itself, and going down every 0.5 millimeter. And since we're working only in the steep areas, I've limited the angles to be working between 40 and 90 degrees. Anything less than 40 degrees will not be considered steep and therefore will not work in those areas. If I take a look at the simulation, you'll see that it's only working on the steep areas of the part. The rest of the areas will be left over for the next operation. And wherever we have a sharp corner, because of the applied fillet, any small radius will automatically have a fillet added onto it so that it does not make any sharp turns within a corner itself. In our next operation, we'll be doing a semi-finish on the shallow faces. For that, we'll be using the option of HSM of linear machining. Again, we'll be using the applied fillet, and the end mill that we'll be using will be the exact same one as we used before, the 10 millimeter ball end mill. And if we go into our passes, again we'll be using the wall offset as in the previous operation with the same step over as well. But this time the angle limit will be between 0 and 42 degrees, allowing it to work only in the shallow areas. And since before we worked from 40 until 90, we'll be having a 2-degree overlap between the two operations. If we take a look at the simulation itself, you'll see that in this operation, it's only working on the shallow areas, not on the steep areas such as this area over here. It will not work on any of the steep areas, only on the flat areas or the shallow areas as shown over here as it goes along the entire part, finishing up all the shallow areas. Our next operation will be using the corners rest machining in HSM to work on the corners. We'll be doing this in a semi-finish on the mold cavities corners. And this semi-finish operation on the corners will enable you to avoid tool overload in the corner areas during further finishing operations. If we were to open up the operation itself, you can see we're using the rest machining option with a 6mm ball and mill. The reference tool will be a 16mm virtual ball and mill, which will determine exactly where this tool will actually work. Again, in the passes, since we're doing a semi-finish operation, we'll be leaving a wall and floor offset of 0.25 millimeters. If I were to run the simulation, you'll see that the tool will work only in the corners, finishing off those corners, and taking off the excess material, avoiding stress on the tool in our later finish operations when you work with a smaller tool in those areas. Now, the rest of the operations will all be the finish operations for this part. So if I'll be working on the steep areas, it'll be very similar to the previous time I worked on the steep areas, only this time we'll be working on a 0 offset. If we would take a look at the tool, we'll be using a 8mm ball and mill, and again I'll be using the applied fillet options to avoid sharp turns in corners. In the passes, as I've mentioned, we're working with a wall and floor offset of 0, doing our finish cut, and working with a smaller step down of 0.2 millimeters. Now, again, since we're working in the steep areas, we'll only be working in areas between 40 and 90 degrees. If we were to run our simulation, you'll see that the tool is working only on the steep areas on the part, but this time it's doing a finish cut, going down to the actual surface of the part. You'll note that it's not working on any of the shallow areas, only on the steep areas of the part. Now, in the next operation, we'll be doing a finish cut on the shallow areas. So just as we worked before in the shallow areas on semi-finish using linear, we'll do the exact same thing here. Again, using the applied fillet option and the same end mill as we used in our previous operation, an 8mm ball end mill. In the passage, you can see we're doing a finish cut, and this time we're limiting our angles between 0 and 42, allowing it to work only in the shallow areas. Running my simulation, you'll see that the tool is working exactly on the shallow areas only. It won't work on these walls over here, only on the shallow areas as shown over here, leaving out areas such as this as well. Our next operation will be a rest machining operation to work on the corners, and just like in the previous time we worked in the rest machining with the semi-finish, it'll be on the same principle in this operation, except this one is doing a finish cut. The tool will be a smaller tool, a 4mm ball and mill, and the reference tool will be a virtual 12mm ball and mill, determining where the 4mm ball and mill will work. In the passes, you can see that this time we'll be doing a wall and floor offset of 0, doing a finishing cut. Taking a look at the simulation, you'll see that it works exactly in those corners, finishing off the corners nicely and smoothly along the entire part. Now, our final operation will be a boundary cut. I'd like to put a small chamfer on these edges over here. So to do that, I've used the option of boundary machining. The tool in this particular case will be a 10mm chamfer drill, And if I were to go into my drive boundaries, you'll see I've used the automatically around the box, giving it an offset of 2 millimeters, taking it 2 millimeters outside the areas of the box. The center of the tool will be 2 millimeters on the outside of that box over there. If I were to go into my passes, you'll note that I gave it a minus 0.2 millimeter floor offset, so it's actually allowing it to go inside into the material itself. If we were to take a look at the simulation, you see the tool goes around the entire part, leaving a nice small chamfer, breaking those edges on the mold itself. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.